All right, ladies and gentlemen, welcome everyone for coming. Today we will be talking about nuclear energy, and we will be talking about it from different perspectives. And the idea is that by the end of this, you will have a better and broad sense of what the pros and cons of nuclear energy are, so you can form your own opinion. We will divide today in 5 subjects, being the environment. We will talk about safety, waste, new development, and the costs of nuclear energy. And during the whole event, we will have this poll up. You can join via slido.com, and you can change your vote throughout the event so that we can monitor public opinion. Now, firstly, I would like to give all the speakers an opportunity to briefly introduce themselves. So we will start with Bob. Go ahead.
Thank you, Zoe. Is this on? Yes. So my name is Bob van der Zwaan. I'm a senior scientist at the Energy Research Center of the Netherlands, ECN, since a year part of TNO. And I'm also a professor of sustainable energy technology here at the Faculty of Science.
Jan, go ahead.
Hello, my name is Jan Haverkamp. I am a senior nuclear expert for Greenpeace and the organization World Information Service on Energy, WISE, both here based in Amsterdam. I'm working on nuclear energy issues for about 35 years. And for Greenpeace, I have to keep an overview on nuclear developments globally, worldwide, with a focus still on Europe.
Hello, my name is Joris van Dorp. I'm an engineer. I work in engineering consultancy for the energy transition. I work on various projects in the built environment for energy sustainable building, sustainable construction for an engineering company. And I'm also a member of the board of the Stichting Ecomodernisme, and I'm a member of the board of TMA from Kiwi.
During this event, we will have the microphone up front right here. If you have any questions at any time, feel free to walk up and we will tell you when we have time to answer them. And if there's no time, you can also, if you think there might not be time, you can raise your hand and we will make sure that we have some time for you.
So I was asked to, first of all, make a very short 2-sentence quote about nuclear energy. And the quote that I came up with is the following, is that for those countries who don't have nuclear energy, think twice before you adopt it. And for those countries who do have already nuclear energy, think twice before you abandon it.
Okay, Jan, and your 2 sentences about nuclear energy?
Oh, for me, nuclear energy has come up back into a discussion after people have not really thought about it for a long time. I'm afraid that talking about nuclear energy is a waste of time, energy, and money. I think that nuclear energy cannot deliver what we need. What it can deliver comes too late, is too costly, too risky, and leaves us with an unsolvable waste problem and an unsolvable proliferation problem.
Okay, and Joris, your opinion? Your 2-sentence opinion?
Well, nuclear energy is actually the most sustainable source of energy that humanity has. And it's essential if you want to solve the greatest environmental problems that humanity has.
Okay. Yeah, Bob, can you give a short factual introduction about nuclear energy?
Yeah, so I will try to do the nearly impossible, which is to summarize this large subject in just 5 minutes. Well, first is nuclear energy's obstacles. And I think it's very hard to overestimate the difficulties of nuclear energy. And there are basically 3 major classical, if you want, obstacles, hindrances. First of all, being waste. The use of nuclear energy generates long-lasting radioactive isotopes that will be around for at least thousands of years, and for some isotopes even millions of years. Second is accidents, as we've seen in 3 Mile Island in the US, then in Chernobyl in Ukraine, now Ukraine, and then in Fukushima in Japan, that sometimes things go terribly wrong with nuclear power. And the third actually is proliferation. The fact that the materials and the technologies that you use for producing nuclear electricity can also be used for military purposes, i.e. for building a nuclear device, a nuclear bomb. Now, those are the 3 classical obstacles. There are 3 other obstacles that are worth mentioning as well. First of all is terrorism. Nuclear power plants themselves are are sensitive for terrorist attacks. And also, nuclear waste can be used in what are called dirty bombs. Second, and that's related with all the points that I've mentioned so far, nuclear energy faces a big issue in terms of public acceptance. In most countries, there are large shares, contingencies of the population who simply don't like nuclear power. And then last but not least, economics. Now, I could here keep a story claiming that actually nuclear energy is very competitive, but at the same time, one can also make the argument that it's very expensive. And with expensive here, I mean that it's expensive in terms of upfront investment costs. So it's very expensive to build a plant. Now, having said all this, one also needs to recognize that nuclear energy does not generate any carbon dioxide. And as we know, we have to fulfill the agreement, the Paris Agreement, by which all nations in the world have agreed to not let the average temperature increase to exceed 1.5 degrees Celsius. Now, in order to achieve that, net greenhouse gas emissions need to be 0 by the middle of the century. And that's a fantastic, an enormous challenge. I think it's one of the main challenges that mankind faces this century. Now, in that context, I think we have to be very careful with abandoning nuclear energy. And there are other benefits as well. The fact, for example, that the energy content of a unit of uranium is simply very, very high, much higher than its fossil fuel counterparts. Nuclear energy, running a nuclear power plant, also does not involve any emissions of pollutants, such as sulfur oxide or nitrogen oxides. So that's yet another advantage. And the last one I should maybe mention is that uranium is very broadly available on Earth by many different countries that are stable providers, and it's very easy to build stocks of uranium. So by using nuclear power, one can actually stimulate a certain level of energy independence. Now, my last statement, if I may, is that all these points that I've just mentioned are more or less facts, and they can all be extensively elaborated. Why do people now, and also nations, differ in opinions about nuclear power? Because they weigh the benefits versus the drawbacks in a different way, and that results them to have very widely diverging opinions. And I think I should leave it here in view of the time.
Thank you. So first, we would like to discuss the environmental implications of nuclear energy. When we think about CO2 emission, efficiency, and the uranium extraction, Joris, what do you think about? What's your view of the environmental applications?
Environmental implications of nuclear. Yeah, well, like Bob already said, the energy density of the fuel of uranium is huge. It's a million times more than coal. So the fact is that if you just get an average rock, it contains 50 times more energy in the form of trace uranium than does a rock which is coal. 50 times more. So you can never run out of uranium, and you don't have to go into sensitive areas to get it. And when you're done with the uranium, you can put it back in the ground, and the ground is already radioactive naturally, and if you put it in the ground, if you put it in glass or if you put it in concrete, you can put it in the ground, and it will not harm anybody. So this is so the environmental benefits of nuclear are clear. There's also a fact, I think. All you need to talk about, of course, is accidents. You know, what happens if you have an accident? Then you have big environmental pollution.
Yes.
Now,
I think we're talking about accidents soon, but I see that Jan is already disagreeing with you. So I wonder if there's something you would like to say in response to the first part of your.
Can I just finish my sentence?
Of course, definitely.
Thanks.
Yes.
Because you know, you can understand. People don't know exactly what it means to have a nuclear accident. It has an impact on the environment and it has an impact on health, but we are never explained what that impact is and how it compares to other kinds of environmental pollution. So that is something that I will come back to because I think it's a very important issue.
Environment and nuclear. Don't get me started. It's a very long story. It's very complicated. That doesn't really matter. I think in the discussion that we're having now, we're facing not just a challenge. We're facing one of the most important dynamics of humankind in its history with climate change. So the question is, can nuclear power really help us reducing our impact on the environment over climate change? And we'll get back to costs later, we'll get back to a few other points later, but nuclear power itself it's a complex technology. At the moment, we produce 17% of the worldwide electricity with nuclear power, tendency going down. And the business as usual scenarios at the moment talk about around 10% of electricity in 2050 to come from nuclear power. There is people who say we need to expand it. And then the scenarios talk about, well, maybe a doubling. Now, if you double the amount of nuclear power now online in 2050, the amount of CO2 reduction compared with business as usual is less than 4%. Just imagine that on 2050 we need to be down 100%. 4% of that is a marginal part. The costs for that are enormous, and we'll get back to that. My point is the largest environmental benefit on which the discussion is now restarted is just not delivering. Apart from that, producing fuel for nuclear power stations is environmentally devastating. I've helped my colleagues investigating the situation in countries like Niger, like Namibia, like Kazakhstan, but also Canada, also the United States. Everywhere where you see uranium mining taking place, there are problems. I myself worked in Eastern Germany and in the Czech Republic, and the legacy from uranium mining there that took place in the 1970s, 80s can be felt still today. That's environmental impact.
And what are exactly the impacts of the uranium extraction?
It depends a little bit on the technology that you use. In most of the places, they have open pit mining, which means very large open pit mines. What you dig out of the ground there gets also pulverized, which means there is dust going around there. Now in Akokan, in Niger, for instance, we've been doing measurements in the town of Akokan, where we found levels of radioactivity where normally spoken people would have to take measures to protect themselves. We've also found waste metal from equipment being used in the uranium mine that was just sold there in the street as scrap metal with radioactivity levels that you would not let your children play near. Now, these are important things. Why can that happen? It's because it's Niger. It's because it's a company that's not under control. And we know that with, I think, every kind of extraction on Earth, also rare metals that we use in windmills, also in others, you need to control that. And that is not different with nuclear power. But as I said, the largest environmental impact or the largest environmental discussion is, can nuclear indeed deliver or not on CO2? And my conclusion is it can't.
So I have a question about that, because you say 4% is the, that's how much we would experience CO2 reduction. How does that compare to other methods of energy? So say we would double the amount of solar and wind energy, what would the benefit be there? I don't know if maybe you know that, or if anyone...
Well, but you say double, you do not talk about doubling solar compared to doubling nuclear. Why not? Well, the thing is, how fast can you ramp up a certain technology? How fast can you expand it? And some technologies are more easy to expand than others. Renewable energy sources appear to be expanding very fast, and it's almost exponential at the moment. So between now and 2015, we can build technically, socially, and economically a 100% renewable energy system. That is possible. There are several scenarios that do that. What we cannot do is double nuclear power. Why not? Well, you need a few very large parts for that. Reactor pressure vessel is the most important part. We cannot ramp up the production of those kind of large parts fast enough to be able to build enough nuclear power stations. So the doubling of nuclear power in 2050 is impossible. So the question is then, is it worth the trouble?
I see that, Bob, you want to react on this?
Yeah, just very briefly elaborating on this. So you correctly mentioned, Jan, that we used to have 17% contribution by nuclear power to overall global electricity production. And you mentioned that in the future this may become 10 or 11%. Well, actually it is already now. I've been teaching a course called Energy and Climate Change, both here and at Johns Hopkins. And over the past 7 years, every year I had to adapt that figure. So 7 years ago I had to say it was 17%. The year after that it became 16%. And right now we are at already something like 10 or 11%. So the relative contribution of nuclear power to overall electricity generation is decreasing. And that much confirms what you're saying, which is that nuclear energy, because it's a technology which is very has a difficulty in catching up with the speed by which we produce and use electricity. Thereby, it has an intrinsic disadvantage. PV and wind, so photovoltaics and wind turbines, do exactly the opposite. Right now, these two renewable energy technologies combined have already a deployment, a global capacity of something like 1,000 gigawatts, which compares to a little bit less than 400 gigawatts for nuclear power. And also the relative role of these renewables in the global energy system, in the global electricity system, is rapidly ramping up. So just from these phenomena over the past 10 years or so, we see a tremendous shift.
Okay, we have a question from the audience.
Is this on? Yes, it's on. I was wondering, because the urgency of taking climate action now is very huge, and you said that we can't ramp up nuclear energy quickly, but suppose we want to, for example, start planning for a nuclear energy facility tomorrow. How long would it take to have it actually be built and be functional?
Yeah, Joris?
In countries that build nuclear power plants today, like China, you can have it finished in 5 years. In Holland, of course, it will take longer because we will have a very long discussion. But I know 10 years, now 10 years ago, Diederik Samson said we shouldn't build power plants, nuclear power plants, because they wouldn't be functioning before 2020. And now he says we shouldn't build them because they wouldn't be functioning because 2030. And if you look back in the history of the anti-nuclear movement, they're always saying it takes too long, it takes too long, it takes too long. So of course, what you should do is you should look at the official studies from United Nations. And the United Nations says that there's basically no scenario where we can have a consumer society like we have now, that you can solve the climate problem without increasing nuclear power. So we already know that we have to increase nuclear power. So if we look at China now, China is very big solar energy and wind energy. That's very good. China is also the biggest in nuclear energy. And China has again decided to build even more nuclear power plants. And they're going to build 1,000 power plants this year. The tariff in China, which is their kind of market system, their subsidy system, the tariff for nuclear is now the lowest of all energy sources, even lower than coal in China, lower than solar and lower than wind. So the Chinese government, which is run by engineers, not by lawyers, run by engineers, they know that they're going to have to build a lot of nuclear power plants because nuclear has a huge advantages. Very low land use, only 1,000 times less than solar power or wind power. Low materials use, low mining, 10 times less than solar and wind power. And of course, extreme safety, 100 times more safe even than solar power. So these benefits have to be employed to help people and nature.
So I think this will be a good bridge to the next subject, right?
Yes, definitely, because indeed our next subject is safety. And this is a large concern for a lot of people, especially after indeed hearing about the events such as Fukushima. And I mean, a big question is how realistic is this risk? Because we seem to remember these big events as really dramatic, and of course they are, but you say it's one of the safest. How can you elaborate on that a little bit? Because I think a lot of us have heard that argument.
Yes, I'd love to elaborate on that. I found out that understanding nuclear accidents helps if you compare the risk with risks that people understand. Now, one risk that we understand is air pollution. Air pollution is an issue. Fine particulate air pollution is, at the moment, is the biggest environmental health risk of humanity. It takes almost 2 years of our lives, almost 24 months on average, globally are removed because of air pollution. In the Netherlands, it's about 4 months that we lose because of air pollution. And in Amsterdam, you lose 30 months because of air pollution. So when you step outside, you're losing 30 months of life expectancy because of the air pollution in Amsterdam. So what do you think is the life expectancy that you would lose if you would live in the center of the Fukushima nuclear accident evacuation zone? Do you have any idea how many months of life expectancy you would lose? I'll tell you the answer. You can find it out for yourself. You will get a dose, a radioactive dose of about 1 sievert during 50 years. And in that 50 years, you will lose, due to that radiation, you will lose a total of 6 months of life expectancy. So actually, the air outside here is much more dangerous, is 6 times more dangerous. 5 times more dangerous. The health impact is 5 times more dangerous than living in the middle of a nuclear fallout zone. So when we talk about nuclear accidents, we have to understand the relative risks. Of course, we have to avoid nuclear accidents, and we can avoid them if we are just careful with our technology. We build a dike that's high enough that the tsunami doesn't go over the dike. That's something that you should do. And if we do that, then we can have no more accidents, and we can have clean air, and we can solve climate change.
Okay, so Jan, do you like to respond?
Well, the first response I have is one of the things we need to forget in engineering. I have both an engineering and a science background. That's sometimes coming in very handy. Engineers try to solve problems. Scientists try to answer questions. That's 2 different things. Now, in engineering, 100% safe doesn't exist. And that's especially true for nuclear power. There is no such, at the moment that you concentrate a large amount of lethally radioactive material, there is a chance it gets into the environment. And we've seen that happening. I've gone through 2 large accidents, Chernobyl and Fukushima. Joris has been in Fukushima, I've also been in Fukushima. We've seen the effects with our own eyes. 200,000 people needed to evacuate. They did not need to evacuate because of some kind of panic or stupidity. They needed to evacuate because they were living in an area where they otherwise would be exposed to radiation doses that are well over the limit of that we internationally have said is acceptable. That limit, by the way, is 20 millisieverts per year. That's the reason why they needed to evacuate. Over 2,000 people have died after Fukushima related to the nuclear accident. And those have all died because of the evacuations. Now, an evacuation is not an easy thing to do. I'll give you one example just as an illustration. The hospital Futuba is 6 kilometers from Fukushima Daiichi. And at the moment that the evacuation order was given, it wasn't quite clear what they should do. So what happened was that the staff of Futuba Hospital was evacuated while 90 people were left in the hospital in intensive care because for them there was no transport possibility. Of those 90 people, 45 died. And they died because they didn't get care, because they didn't get food, because they didn't get water. That is an awful tragedy that was inevitable because mass evacuation is such a problem. And that mass evacuation was necessary. That is to illustrate for you that accidents are not just something to really gloss over. We cannot say nuclear power is safe. Those accidents, they just happen. If you try to imagine what it would be here in the Netherlands when anything would happen in Doel or anything would happen in Borselen, I've been involved in a lot of assessments of our emergency preparedness here. It would be chaos. I can really guarantee you that.
I see some disagreement here, and I wonder if it has something to do, because I understand that you're saying that nuclear, like a nuclear disaster obviously has huge implications, and it partially has to do with the evacuation process. However, how does that compare to other
Well, if you have a fire in a wind turbine.
Yeah, but a fire in a wind turbine. But you're talking about, for example, a dam breaking through that can kill so many people, and I wonder how that also has to do with evacuation. So how does that compare? I don't know if anyone has the answer to that. Go ahead.
Well, I do have the answer. Actually, the scientific community is working now, has been working since Fukushima to adjust emergency response. There are manuals which are used to protect the public in case of severe conditions at a nuclear facility. And the conclusion is now that relocation, taking people from their homes, is never the best response to a nuclear accident. Because they've looked at Fukushima, they've seen what happened. People have been literally forced out of their homes to achieve what statistical 4 days of life expectancy gain. 4 days. To be taken from your homes for 5 years. So the scientific community knows that we have to work on accident response. So when there will be another nuclear accident, maybe in 30 years, hopefully, of course, there will never be one, but the next time there is one, we are not going to be tearing people out of their homes and killing them because of a risk that is completely exaggerated.
Well, that is not the reality, Joris. I'm very sorry. The scientific community, first of all, has a consensus about the potential effects of radiation. It's called the linear no threshold model. That's a hypothesis. We have not been able to prove it, but all the research at the moment shows that it's the most likely description of the relation between health and radiation exposure. On the basis of the LNT, there have been limits set of the risks that we deem acceptable. Now, of course, you can say there are some people that...
I don't dispute LNT. Can you skip to a next question?
Maybe Bob can tune in.
I think the short summary of this discussion is that actually there are three things that one needs to take into account when talking about these environmental effects. It's mortality, first of all, so the number of people who can possibly die because of accidents. But it's also morbidity, which is the number of people that can get ill, get cancers because of accidents. And then finally, I think, which is also very relevant, is the number of people that may need to be displaced because of major accidents. And that is, I fully agree with Jan, a major issue that nuclear power is characterized by, and many of the new renewables, except for hydropower, not. Having said all this, looking just at that first parameter, so mortality, I'm wondering whether students know the number of people that die every year on a global level because of air pollution. And air pollution both because of coal-based power plants and of cars running on petrol. Are these tens of thousands, hundreds of thousands, or millions of people dying every year?
So who's thinking millions? Tens of thousands? Okay, so
so it is actually millions. So the World Health Organization quotes these figures. You can look them up and Google them. It's something like 3-4 million people dying every year because of air pollution. Now, contrasting that with the number of direct deaths of these three major accidents that happened since the 1970s, there's none in 3 Mile Islands, 42 in Chernobyl, and 2, if not 1, at Fukushima. These numbers, of course, are vastly different. And even if you take into account all those people that got contaminated in the Chernobyl area, and as a result got thyroid cancers, then at most, and that's again a quote from the World Health Organization, you get at most something like 10,000 deaths. So still 2 orders of magnitude difference from what happens because of air pollution. So I think contrasting, and there I fully agree with Joris, contrasting these figures in terms of mortality is very relevant.
I just want to contradict you there on one point. You mentioned the 10,000 of the WHO, but that is a number that is coming from a Swiss study that has been assessing a limited group of people. And that was a limited group of liquidators together with a limited group around the nuclear power station. And they came to an assessment which has for one of those subgroups 4,000, another 9,600. But the author of that study has taken distance from the conclusion that was taken by the Chernobyl Forum and the WHO that this was the final number. So we talk about 10,000, and I agree with you, for long-term mortality, that is the under limit, roughly in estimates. The upper limit is a lot higher. It will be impossible to say how many people in the end have died because of Chernobyl. But the amount of people is in the 10,000s. And I think that it is important to keep in mind. Every time again we will see that people from the nuclear industry are trying to whittle it down to the 32 or 52 or 58. 26 I heard lately again. That is an attempt to divert the discussion from what the problem really is. Chernobyl was an immense problem. It's an immense problem of 600 billion euros of costs to Europe. It's a problem of 120,000 people evacuated. And those are problems. And I think we should not gloss them over.
So we have a question from the audience first, I think.
Yeah, I was wondering, the design and methods used in Chernobyl, are those still in use nowadays?
17 reactors in Russia at this moment are still of the RBMK design.
And how many are there globally?
That is globally, because Russia is the only one still.
How many
still
reactors
running.
in total are there globally?
In total, there is 441 reactors operating, 439 reactors at the moment operating. And the Fukushima type is a boiling water reactor, is also still in operation. There we talk about roughly 100. But also the pressurized water reactors, the most normal design that we see everywhere, has its chance on severe accidents.
Lotus, you want to?
Yeah, I'd just like to add, I mean, we can throw around figures all day. We've already seen that there are 3 million deaths each year from air pollution. Nuclear could be somewhere between a few hundred and maybe 10,000, which I don't agree with, actually. But there's a lot of science here. This has actually been studied. A huge number of scientists have been studying all these issues. If you really want to understand these issues, World Health Organization, United Nations Scientific Committee for the Effects of Atomic Radiation, they have explained everything. I'm correct, he's wrong. But you can just send an email to our society, the Ecomodernisten Society, and we will send you an email with the links to the science, and you can look it up yourself and read it, and then you can find out what the truth is. Don't be afraid of nuclear energy, and don't be afraid of nuclear accidents.
Just for your information, Joris refused to take safety measures when he was going into the safe zone around Fukushima, because he doesn't believe that radiation can do anything for you. All the other people needed to take some basic safety measures when doing that. Now, I am a radiation protection advisor, and I've studied for that, and I'm certified.
Okay, before it gets too personal, maybe we can do the other
So
question.
at that moment, I mean, I know that you do have to take precautions, and these precautions are just wise to take.
Understandably.
All right.
So we have
Question
time
time?
for one question right now.
Is it working? Oh, sweet. I was pretty curious about the evacuations. Are we talking about permanent evacuation, or are we talking about taking people out of the area for a particular amount of time and then allowing them back in?
For Fukushima, we talk about 160,000 people evacuated. 30,000 will not be able to return. At the moment, about 40,000 are still in the category of evacuees. A lot of them, of the other ones, between 160 and 40, have not returned. We see return rates lower than 26% in areas that have been opened up because they have been decontaminated and where people are allowed back. And those are mainly, or the largest part, are older people.
All right.
The reason is that very often people have been displaced for 8 years. They've built up a new life. That's one. Second is you see very often families with children, they are wary of returning because if you return, you need to fulfill certain safety measures yourself. So the kids cannot go into the forest, for instance, because the forests have not been decontaminated.
All right. Well, I had a second question.
Yeah, I think we have to move on to waste.
All right.
Sorry.
Thanks.
Yeah.
Okay.
Maybe at the
Actually,
end.
I also wanted to respond just very shortly,
Very shortly, yes.
on the Fukushima. I was in Fukushima. We visited a town where people had returned. It was a safe town. The contamination was not very high. And I was with a group, and what they wanted to do, they wanted to walk into that town with full protective gear in order to scare the population. There's a fear-mongering. And I said, no, this area has been declared safe by the Japanese government. We are not going to go in here with unnecessary safety gear when people are walking over the streets with their children. Now, they didn't agree with me, so they put on their gear, and I refused to do that. That is inhumane.
Okay. So we want to continue with waste because this is a big concern when talking about nuclear energy due to the slow degradation of the waste. And it needs to be stored for an extensive period of time. So yours, how do you solve this problem?
Yeah, A problem, yeah. I mean, you know, nuclear waste is the only waste problem that humanity has actually been able to solve. Literally the only one. Every form of energy provision causes waste, and all of those forms of waste kill people. Nuclear waste is the only form of waste that doesn't kill people. And why is that? That has to do with the concentration of the energy. So if you have 1 kilogram of nuclear waste that has been used, concentrated nuclear waste, 1 kilogram, has provided 400,000 euros worth of energy to society. So we can afford to take care of that waste very carefully. And that's what we do. With fossil fuels, with solar panels and wind turbines, even with solar and wind, the waste is has very high volume and very high mass, and is very difficult to take care of, because you simply don't have the money to do that. You already need to have money subsidized to build them, and then you don't have any money left to take care of the waste afterwards. So I'm not saying that waste from solar or wind is a problem, and actually the waste from fossil fuels, if we can pump it underground, the CO2, then it's also fairly okay to solve. But nuclear waste is by far the easiest and the safest waste form of all energy technologies.
And first Bob wants to reply.
Why the world is spending billions and billions in trying to find what we can do with spent nuclear fuel or with vitrified waste after reprocessing, which is at the moment, if you would not put it into a safe storage, lethal if you stand next to it. Yeah, because it's so easy to solve. Well, let me tell you one thing. The reality is that for the high-level waste that we have from radioactive, from nuclear power, and we have worldwide around, or a bit more than 350,000 tons of that. No, 350,000. That is the number that that is the number from, the total of spent nuclear fuel at the moment is 350,000 tons. I can give you the quote afterward if you want. Tons, yeah, 350,000 tons. That means if you calculate it, that means 350 large swimming pools. Good, but that amount of waste needs to be kept out of the environment for a period of several 100,000 years. We've tried to find ways of doing that. We've tried it in Yucca Mountain in the United States, but a tough underground there is not secure enough, so that project has been cancelled. We're trying to do it in Finland in granite, where we use copper canisters and clay to keep the water out. But it appears that we will not be able to guarantee that we can even prevent it from leaking within 10,000 years. Apart from that, there is the problem if you put it away in the ground. For the next 4,000 years, you will be able to use the plutonium that it contains still for weapons. So what do we do? Are we going to tell people it's there, you need to stay away? And then if you want to make a plutonium bomb, you do not build a reactor anymore, you just dig and you do your chemistry? Or do you say we try to forget it? We try to forget where it is. And then what might happen is that somebody by coincidence bumps into this waste, and there is a joke which is made by one of the Finnish groups that are trying to take care of the waste. They say, well, we're digging now. Imagine that we find here 5 tons of copper, a huge box. What do you think we'll do? That's how Finns laugh always. So of course we'd open it, yes. But radioactive waste is a problem.
Okay. So what do you think about it?
Yes, a couple of remarks. So I would definitely not claim that, like Joris does, that nuclear energy does not have a waste problem. I think it's actually one of the biggest waste problems that any energy technology currently has. Now, in terms of volumes, you could argue that actually we don't produce that much every year. As I mentioned earlier on, we have something like 10% of all our global electricity provided by nuclear power. And the waste, the high-level waste, I mean, coming from that amount of electricity, fits roughly here in this space. If you divide that by the number of people on this planet, you get every year something like this. So it's a very, very small amount. I took this from the toy box of my little son. But that's not the issue. So it is indeed very, very small, but the issue is the toxicity of the material, and especially the radio toxicity. This stuff needs to be stored somewhere, and in many places, many countries in the world, currently this is done above ground, simply because they haven't been able to figure out yet how and where to do this below ground, deep underground. And one of the countries, of course, is this one. In the province of Zeeland, we store this stuff in a big bunker, which is designed only to last for 1 century. And material, as I mentioned, lasts for thousands of years, and for certain isotopes, even millions of years. In the US, there has been a plan to store all this nuclear waste coming from these 100 power plants across the United States in Yucca Mountain. Now there have been extensive studies being done in Yucca Mountain for decades, trying to figure out whether that waste would stay there for tens or hundreds of thousands of years. And scientists simply do not know. They see so many uncertainties and so high risks of ultimately this waste starting to leak that they, to date, still have not been able to take this plant into operation.
Okay.
Now, if I may, one last remark, and that's to put this yet again a little bit into perspective of proliferation, which is that the good aspect of this high radioactivity of this waste is that the plutonium that is embedded in it is just very hard to retrieve. So it is not very easy at all to produce nuclear bombs of the plutonium embedded in this material. It's once this plutonium is separated, that's when the criticality for nuclear weapons
Which is the
proliferation,
situation we have for the Netherlands, for instance. We separate the plutonium, and if it is not, I mean, the question is, what is happening with the plutonium? It's at this moment the plutonium is still in La Hague,
I have to interrupt for a second because we have a question right now, and
so we have the plutonium problem.
We need to have our question right now because we're running a little short on time. So
I have a radical idea to solve the nuclear waste problem. I was just wondering what your opinion is on it. Let's say we take all the nuclear waste that is produced, store it for 100 years to get the short-lived isotopes out of it, get the radiation down a bit, then we grind it up and we spread it through the soil evenly over the entire Earth. How much would the background radiation then rise on Earth in percent?
That's an interesting question. No, actually the radioactivity is very high, so you could probably have a measurable effect even at that scale. So I'm not saying that you have to that you can just throw it all over the place. But I would like to say one thing about plutonium, because indeed the nuclear, when you're talking about nuclear waste, you're talking about plutonium. All the other stuff is actually, well, there's a little bit more stuff, but mostly it's plutonium. And the thing is, if you leave the plutonium inside the spent fuel, then you get these large numbers of huge amounts of tons and very difficult and No, you have to get the plutonium out, and that's what the French do. They do it very well. They take the plutonium out, and you put the plutonium back in the reactor. Because then your plutonium works like uranium. It's more fuel. So you can just have a recycled system. So when I talk about nuclear waste, and also my expert colleagues, we see nuclear waste as only the fission products. So the fission products you put in a place, after 100 years, 200, 300 years, that has turned into valuable stuff like platinum, palladium, ytterbium, all the rare earths. You have a treasure. You know, you put it in a vault, and then after a few hundred years, you have treasure. That's nuclear waste. It's not waste, it's treasure. And the plutonium you put back, you work like uranium, and then you get infinite energy. Simple.
Maybe study what is happening in La Hague and in Sellafield. Yeah, of course
I know all
you
about
know
that.
everything, Joris. I know
I'd
that.
like
But
to
the
do
only
another
thing you don't know
question.
is the
But would the
complexity of
background
it.
radiation go up like by a factor of 2, 10, or 100?
The nuclear tests, nuclear bomb tests that we've had are, I think, the nearest that we can come to an estimation there. And they have added up to, if I'm not wrong, about 20% on the background radiation in places where there is quite a bit of background radiation. For places where there's little background radiation, it's of course less. The only problem is you're going to spread it. Is there a chance that people will inhale material or get material in their system? Because ingestion of radioactive material is a lot more harmful than getting the radiation only from outside. There's something you have to keep in mind. So if you spread it, you do not want your plutonium particles, your hot particles, to end up in the food chain. I don't know how you're going to do that. I mean, that's a very difficult one.
Yeah, that sounds like good. We have one more question.
Yeah, I was wondering if you could just shoot all the waste into space.
Have you ever looked at the amount of rockets that don't make it into space?
That's a very good point, thank you.
And we have that point of spreading from nuclear weapons, and you should not underestimate what that has done also on health effects. Another example there is the Netherlands, Switzerland, Germany, France, UK, and Japan, and Russia and the United States. We have had a very bad history of dumping radioactive waste in sea. And also there what we see is we thought it would spread throughout the sea, so it's gone. But what we do see is that still in the dumping grounds in the Gulf of Biscay and south of the UK, we see their concentrations in living material of radioactivity stuck there even 40 years after. And the question is again, what does that material do in the food chain? So we need to find a solution that we keep it concentrated on one place. And the conclusion is it's very difficult. Now we do have a certain amount of waste, and we, that is me, and I would even say I'm always ashamed to say, and it also includes you and your children and your great-grandchildren, are the ones that have to take care of that. That's a responsibility we have, and that will not go away. We have to find something.
Because of the time...
Deep geological disposal might be a solution. There may be even other solutions. And we think about extremely deep storage, 4,000 meters under, or we talk about fully engineered storage. So something that we can control completely and will have to roll over to future generations. It's really complicated.
Okay, we can touch on this a little bit more later. I want to give Joris a short chance to reply, and then after that we have to move on to what's going to be the last part, which is going to be new developments. But first I thought you wanted to say something to finish this.
I'm sorry, I forgot what I was going to...
That's okay, because I would like to get back to something you were saying about finding like the materials from nuclear waste and actually recycling them, because the next subject is going to be new developments. I'm assuming that is a process that is being, you said it's being used in France right now. Is there any way we can further develop these techniques? And besides that, what are other techniques that can help nuclear reactors become safer? Because of course, we're talking about Fukushima, we're talking about like relatively old reactors, and there has been a lot of arguments that the new ones are a lot safer.
I can say something about that if you want. So I'm among those people who have got relatively, I would call them nuanced or mitigated opinions about nuclear energy at large. But I am a big opponent of reprocessing, of recycling, for a couple of reasons. And recycling, by the way, means the plutonium that you create while running a reactor, trying to get it out and then use that as a fissile material in new nuclear fuel. Now, first reason is that there is enough uranium on Earth. There are huge quantities, so you don't really need to do it. Secondly is that we don't really need to reduce very much the volume of waste, because as I pointed out earlier on, the volume of the waste is not the issue. It's the radioactivity of the waste, which is the crux. And recycling doesn't solve that. Thirdly, and perhaps most importantly, is the fact that once you separate your plutonium, it becomes available for use other than civil purposes. That means producing fissile devices, nuclear bombs, or perhaps even simple gun-type devices that can be produced by terrorists. And last but not least, and that's maybe the subject we're still going to talk about in the last 5 minutes, which is economics. The economics, we did extensive studies on the economics of reprocessing. The economics simply do not work out. It's very costly and with no clear benefits. Thank you.
Well, there is, of
Sorry,
course...
this was very anti-nuclear, so can I respond to this?
Yes, of course.
Yeah, no, I hear the arguments, and there's something to be said for those arguments. But on the other hand, I mean, if we're going to do what the United Nations climate panel says, which is that we have to solve the climate problem, the CO2 problem, we're going to need a lot of nuclear power plants. And eventually, in the second half of this century, we're going to have to build breeder reactors. And that's exactly what the Chinese are going to do. The Chinese are going to build breeder reactors. Now, breeder reactors work by recycling plutonium or using thorium. So that's another option. So these technologies, they're known, they've been proven. The Russians have a breeder reactor that's running now, a commercial size. So we know these technologies work. They're not expensive. The cost is very low. The Russians aim to provide electricity from breeder reactors for 2 cents per kilowatt hour. That is low enough that you can have zero carbon hydrogen production, and we need to have zero carbon hydrogen production to have airplanes and make synthetic fuel. So the breeder reactors, we know that they work, we know that they are safe, and we also know that they are proliferation resistant, because the funny thing is that if you have the plutonium and you have it in the reactor, then it becomes contaminated. So you can maybe make a gun-type device. I know that argument, but no. Nuclear weapons are built by states who want to protect themselves against other nuclear weapon states. That has nothing to do with civilian nuclear power. No terrorist will ever be able to make a nuclear weapon, but only states can do that. So North Korea doesn't have any nuclear energy. It does have nuclear weapons. Why? Because you don't need to have a nuclear power plant to build a nuclear weapon. So when people say we can't have nuclear power because otherwise we will have nuclear weapons, that's not true. In fact, Germany is now working on a plan to build nuclear weapons because Trump has said that he will remove the nuclear shield from Europe. So now Germany, Britain and France are working together to have a nuclear weapon launch in Europe. So nuclear weapons are nothing to do with nuclear energy. That's my point.
This has been reason for a question?
Yeah, I have a question. But what if you would just drop the nuclear material in our groundwater? What would happen if you just drop the nuclear material as a terrorist into our groundwater? What would happen then?
Well, it really depends exactly what kind of material it is, of course. But we know from nuclear accidents, if you have, for instance, soluble materials such as cesium or iodine, radioiodine, if you get that, then it concentrates in your thyroid gland, and you can have thyroid cancer from that. So the question is, can these terrorists get hold of radioiodine? Well, that's not possible because the radioiodine disappears very quickly. Cesium is another one. Cesium is long-lived, but also almost impossible to get it. So these dirty bomb threats have been studied by the Pentagon in the 50s and the 60s, and the Pentagon has said that dirty bombs have no utility. They're not useful, not for warfare, not for terrorism, not for nothing.
I was not talking about a bomb. I was just simply asking whether dropping it into our groundwater and also with the long-term nuclear materials.
There are many ways that you can use radioactive substances either to cause damage or to scare people. So you can use them for, and that's what the scenarios that you mention, is one of the scenarios that are possible there. And that's important to keep in mind. If we talk about radiation and security, so preventing that people get their hands on radioactive materials and do things with it, you do not only think about these scenarios involving bombs, but indeed also dirty bombs. And that is one of the reasons that radiation security is an important point of attention for all operators of nuclear installations, not only of reactors, also of research reactors. I want to come back still about the future developments, because I think that's important. There is a lot of hype at this moment about new reactor designs. In the Netherlands, strangely enough, it is the liquid fuel thorium reactor that is a lot in discussion, and that is because we have one professor in Delft who is angling for about 2 billion he needs for pushing forward his research program on thorium. I've been very closely studying all these new designs, and we talk about 12 to 15 new design types. For me, the most important conclusion has been drawn by the French Nuclear Institute, ISN, in an overview study of all these new designs, and they say, first of all, these designs are not going to deliver us cheaper energy. The cost, the expense that we need to put into it will deliver electricity that is about as expensive as the current third-generation nuclear power station, and that is twice current market price. So it's very expensive. Next to that, each of these designs has its own advantages and drawbacks. For thorium, for instance, proliferation is for me the nightmare. And there are two ways that you can use thorium reactors for proliferation. One is you mix depleted uranium into it and you harvest the plutonium. The other one is you harvest palladium-233 and you let that fall down to pure uranium-233, which you also can use for bombs. Now, you said already it's very difficult to get that, the chemistry. The problem is just that for thorium reactors, you need to deliver the chemistry with it, because thorium reactors need reprocessing, constant reprocessing. So if you get a thorium reactor in your country, you also get all the technology you need to be able to either spike it with uranium-238 and get out the plutonium, or to harvest palladium-233. That is a very big risk for countries that would like, and I talk countries, I don't talk terrorists, I talk countries that would like to make a problem. All the other designs have similar problems around proliferation. So if you cannot completely solve the waste problems, but only a part of it, only partially, if the costs are as high as they are for nuclear power now, which means it's been priced out of the market. If it is still a proliferation problem, why would you do it if you don't need it? Because we do have alternatives. And I think that is, for me, the most important conclusion.
Okay, thank you, everyone, but we have to end, so please.
Yeah, can you maybe tell us about a poll?
The poll, so it's hell yes, 50%, tell me more, 31%, and oh no, 19%.
So, and did it change throughout this?
Yeah, in the beginning it was tell me more, which was on 48%, and then after a while, oh no, it's 28, and then after a while, the hell yes came up more and more.
Okay.
So,
All right.
So thank you everyone for coming. Next month we have an edition regarding plastics. So hope to see you all there. If you have any questions, you can come up to the stage and ask something. We're still searching for new people in our committee.
If people also have still questions they would like to discuss a bit further, I can stay for another hour.
Yes, I was going to offer that too, because obviously we've ended on a bit of a short note, but feel free to come up and talk to us about anything. And I want to thank the speakers very much. I think it was a very interesting discussion. Thank you very much for joining.